This presentation represents one of the final outputs from a project which has explored the relationships between spatial inequality and attitudes to inequality in South Africa. The project has been a collaborative undertaking between researchers at the Centre for the Analysis of South African Social Policy at the University of Oxford and the Human Sciences Research Council in South Africa. The project has been primarily funded by the UK's Economic and Social Research Council, with some additional funding contribution from the South African National Research Foundation. There are three components to the project. The first component focuses on the development of new measures of inequality, and specifically spatial inequality, in South Africa, with a particular emphasis on measuring how people's experience of inequality may vary spatially according to where within South Africa they live. The second component of the project interrogates the South African Social Attitude Survey to better understand people's attitudes to inequality and their attitudes, views and opinions on options for redress in South Africa. And finally, the third component of the project draws upon the findings of the two preceding components to test whether there are any statistical relationships between people's experience of inequality, according to where they live, and their attitudes to inequality. So, are people's attitudes to inequality in South Africa influenced by their experience of inequality as they go about their daily lives in their local geographical settings? This particular presentation focuses on the third and final component of the project, namely, testing whether people's attitudes to inequality are influenced by their exposure to inequality. In the presentation, I will first set out the key research questions that we interrogate. I will then give a summary of the data preparation steps involved. I will give a brief overview of the model development process. I will highlight some of the key empirical results, and then conclude with some policy implications. So in this project, we essentially looked at two separate dependent variables as our key research questions, both of which were drawn from the South African Social Attitude Survey in 2009, or SASAS 2009 for short. The first of the two research questions focuses and relates to people's aversion to income inequality in South Africa. So question 186 of the SASAS survey in 2009 asks respondents, to what extent do you agree or disagree that differences in income in South Africa are too large? The second research question focuses on issues to do with redress, and particularly it asks respondents whether they think that the government has a responsibility to reduce the differences in income between people with high incomes and those with low incomes. This is question 187 from the same SASAS survey. And of course the key motivation in this whole entire project has been to assess whether or not people's responses to these two questions are influenced by or associated with and shaped by their experience of inequality, their experience of socio-economic inequality as they go about their daily lives. So for the purpose of this project, we developed four separate complementary statistical models. As I've just mentioned, we have two separate dependent variables, those being aversion to income inequality and views on government responsibility for redistribution. And we have models for two subsets of the population. We have the poor subset of the population and the non-poor subset of the population. And this is because, as part of an earlier phase of this research project, which is discussed in a separate presentation, we constructed two separate but complementary empirical measures to reflect people's experience of socioeconomic inequality. There was one measure which reflects the experience of socioeconomic inequality from the perspective of the poor population, and another measure which reflects the experience of socioeconomic inequality from the perspective of the non-poor population. So our four models include Model A, which is aversion to income inequality from the perspective of the poor; Model B, which is aversion to income inequality from the perspective of the non-poor; Model C, which is support for government responsibility for income redistribution from the perspective of the poor population; and finally Model D, which is support for government responsibility for income redistribution from the perspective of the non-poor population. In terms of data preparation, there were three major tasks. The first major task was data linkage. We had individual respondent level data from the South African Social Attitude Survey, and we have neighbourhood level indicators of exposure to socioeconomic inequality and neighbourhood poverty rate, which were generated earlier in this project. And we had to link together these two separate data sets in order to be able to test whether the individual level responses to our dependent variables were influenced in any way by the neighbourhood level exposure or poverty rate variables that we had constructed. The second task was to select the relevant control variables to feed into the model process. And the third task was to split this linked dataset into two subsets. One subset for the poor respondents and another subset for the non-poor respondents. And I'll talk through each of these three tasks in a bit more detail now. Firstly, with regard to data linkage, the exposure to socioeconomic inequality variables, which we constructed earlier in this project, were constructed at the data zone neighbourhood level. And I'm presenting a map here showing the whole of South Africa and how the levels of exposure to socioeconomic inequality from the perspective of the poor population are geographically contoured. We also have individual level respondents in the South African Social Attitude Survey. And what we need to do is to merge these two datasets together. Now, unfortunately, the SASAS, the South African Social Attitudes Survey, does not contain a data zone level code or identifier within the dataset. However, the survey does contain the enumeration area of the home residence of each survey respondent. And fortunately, the data zone neighbourhoods, which are the basis for our exposure to inequality scores, these data zone neighbourhoods are themselves constructed as groupings of enumeration areas. So using the enumeration area as the key match variable, it was possible to assign each individual SASAS respondent to his or her home data zone neighbourhood. And through that, we were able to assign the data zone level exposure to inequality scores to each individual respondent and the data zone level poverty rate to each individual respondent. The second data preparation task was to select the appropriate control variables to feed into the model. So the South African Social Attitude Survey in 2009 had a vast array of variables within it, under a range of different themes. So the project research team sat together and reviewed the entire questionnaire from 2009 to identify a selection of potentially important control variables. A manageable number of potentially important control variables were identified, and these were extracted to generate a base modelling dataset. And these variables which were extracted of potential importance spanned a range of different themes, including demographics, objective personal life status, subjective personal life status and dynamics, perceptions of intergroup societal tensions, views on individualistic versus structural factors underpinning success in life, political views, and some geographical identifiers. And I'll talk through each of these variables in turn now. So this is the final set of selected control variables, and indeed our dependent variables, which fed into the modelling process. So firstly, we have the individual unique identifier from the survey. This wasn't actually used as a modelling variable, but it was in the modelling dataset. We had a composite survey weight, which was constructed by the Human Sciences Research Council in the construction of the survey. Our two dependent variables in the modelling process, which I discussed earlier, so aversion to income inequality and support for government responsibility for income redistribution, and then a series of independent explanatory variables. So in terms of demographics, we have some variables on respondent age, race, marital status and household size. We have a derived indicator relating to material asset ownership, which is based on 25 separate questionnaire items, such as, for example, does your household have a washing machine in working order? And I'll come back to the asset index variable in a moment. Some objective personal life status variables, namely level of highest education achieved and current employment status. And then some subjective personal life status and personal life dynamics variables, such as self-perceived poverty status, a question which asks individuals to place themselves in terms of their perceived location in the social hierarchy between the top and bottom of society, a question on a respondent's perceived social mobility over recent years, and a similar question on respondents' expected future mobility over the coming years. Question on whether or not the respondent's job is perceived by the respondent to be of a higher prestige than his or her father. Then a couple of questions on perceived intergroup societal tensions. We have a derived class conflict index based on multiple separate items, such as, for example, in your opinion, in South Africa, how much conflict is there between the working class and the middle class? And then a question on whether or not the respondent feels that he or she is part of a group that is discriminated against in South Africa. We then have 3 questions on individualistic versus structural factors underpinning success, a derived merit factor index relating to issues around the importance of merit for getting ahead in life, such as how important is hard work for getting ahead in life, a derived exogenous factors index based upon separate items, such as how important is coming from a wealthy family for getting ahead in life, and then a separate individual question asking how important is a person's race for getting ahead in life. 2 questions relating to people's political views. Firstly, asking people to place themselves on the left-right political ideology spectrum, and a question on whether or not the individual would vote for the ANC or not if an election were held the day after the survey was undertaken. Then some geographical information, such as the Statistics South Africa geotype classification relating to the enumeration area of home residents, the data zone neighbourhood identifier code, the local municipality identifier, and the province identifier. And these are all internal to the South African Social Attitude Survey. And then we have 3 external indicators that were merged on, as I explained in the previous slides. These are constructed by ourselves as part of this research project and constructed at the data zone neighbourhood level. We have exposure to socio-economic inequality from the perspective of the poor population, exposure to socio-economic inequality from the perspective of the rich, or rather of the non-poor population, and we have the poverty rate of the home data zone neighbourhood of the survey respondent. So overall, a fairly broad set of explanatory variables to test, mostly taken from the South African Social Attitude Survey as control variables, and then our 3 neighbourhood level variables which we've merged on, which was the particular focus of this research project, because we want to assess whether or not there's any evidence that these neighbourhood level variables affect the individual level dependent variable responses. The third major data preparation task was to split the SASAS survey respondents into 2 separate subsets, one relating to the poor respondents and another relating to non-poor respondents. So the exposure to socio-economic inequality measures, which we produced earlier in this project, utilise the dichotomous classification of poor and non-poor as defined for the income and material deprivation domain of the South African Index of Multiple Deprivation 2001 at data zone level, or the SAIMD 2001 for short. Now, according to the SAIMD 2001, across South Africa as a whole, 73% of the population is classified as deprived, or poor, on the income and material deprivation domain, with the remaining 27% of the population regarded as being not deprived, or not poor, on this domain. Now, our exposure of poor explanatory variable that we constructed earlier in this project is only relevant for SASAS respondents who would be regarded and classified as poor themselves. And similarly, the exposure of rich explanatory variable is only relevant for the SASAS respondents who would be regarded and classified as being non-poor. So, if we have a SASAS respondent who is very clearly affluent, then it's not appropriate to include the exposure of poor explanatory variable in explaining the affluent person's responses to dependent variables. And equally, if we have a very poor individual, SASAS respondent, it would not be appropriate to include the exposure of rich explanatory variable in the model trying to explain the very poor person's responses to the dependent variable. And as such, it was necessary to split the SASAS dataset into 2 subsets, one consisting of the poor respondents and another consisting of the non-poor respondents, and then to run models separately for these 2 subsets, and including in each of these 2 subset models the relevant exposure indicator. So in 2009, the entire SASAS dataset contained 3,156 respondent cases. And as I just explained, our modelling requires a split of 73% poor and 27% non-poor. Now, SASAS does contain a question on respondent and household income, However, there were many missing cases and many cases of not stated income, which together mean that this is not a reliable variable. Fortunately, however, SASAS also contains serious questions relating to material asset ownership, and as I briefly mentioned in an earlier slide, as part of this project we derived an asset index score enabling each survey respondent to be ranked from the lowest asset ownership to the highest asset ownership. And it was this asset index variable that we used as the basis for subsetting the SASAS dataset into the poor and non-poor subsets. So the 73% of SASAS respondents with the lowest asset ownership were assigned to the poor SASAS subgroup, and 27% of the highest asset ownership respondents were assigned to the non-poor SASAS subgroup. Moving on to discuss the actual model development process. Our two dependent variables, which is inequality aversion and support for government redistribution, are both on 5-point ordinal scales. After consultation with colleagues in the University of Oxford Department for Statistics, it was agreed that cumulative link ordered logic regression models were therefore required. Some initial tests showed that multi-level models were required due to geographical stratification employed in the SASAS sampling method. And all statistical models developed and implemented in this project were implemented in the R statistical software package using the CLNN function from the ordinal library. So as I mentioned earlier, we produced 4 separate but complementary models, models A, B, C and D. And each model started off with a full complement of model-appropriate explanatory variables listed above. So models A and C, which relate to the poor subgroup, contained the exposure of poor explanatory variable, whereas models B and D, which relate to the non-poor subgroup, contained the exposure of rich explanatory variable. The multi-level component consisted of 3 nested levels, these being the individual respondent, the data zone neighbourhood of home residence, and the local municipality of residence. Now we treated the ordinal and categorical variables as factors, and we standardised the numeric and ratio variables by subtracting the mean and dividing by the standard deviation. The actual model development process was based upon a paper by Greenland in 1989, and we started with a full complement of explanatory variables in our base modelling file, as I've just mentioned. And then we undertook a process of sequentially dropping one variable at a time based upon a likelihood ratio p-value until each variable remaining in the model had a p-value of less than 0.05. And the aim of this was to develop the most parsimonious as possible model. Now, the exception to this is that the explanatory variables relating to experience of inequality, these being exposure of poor or exposure of rich, and the neighbourhood poverty rate, and the interaction term between them, would be retained in the model regardless of LR test p-value. And this is because it's these neighbourhood level variables which we particularly wanted to test whether or not they had an influencing impact upon the dependent variables. Now, once we slimmed the model down as far as possible, we then tested for interaction terms between our neighbourhood level explanatory variables and some of the other individual level control variables. And where such interaction terms were found to be statistically significant at the 0.05 level, these interaction terms were added into the model. So in terms of model development and the final specifications, I won't go through this term by term, but Model A, which related to inequality aversion as our dependent variable and from the perspective of the poor subgroup. We had Model B, which was inequality aversion from the perspective of the rich subgroup. Model C, which was support for government role and redistribution from the perspective of the poor subgroup. And Model D, which was support for government redistribution from the perspective of the rich subgroup. Now you can see that the model specification is different for each of these four models, because each of these model development process was undertaken separately for each of these. And there's a little note here to say about how we have suffixed some of the variables names after the standardization. We turn now to the results. Now the focus in this presentation is on models A and C, which relate to attitudes towards inequality amongst the poor subgroup of the population. However, the accompanying project research report contains a full series of results from all four models. So moving on to some of the results, starting with Model A, which, just as a recap, is inequality aversion amongst the poor subgroup. And this is a table which is extracted from our project research report, which shows the full in detail of all the model terms, coefficients, and odds ratios and confidence intervals. And we can see the structure of this table. We start off with the respondents' personal and household characteristics. We then have a section on respondents' attitudes and views, a section on geographical location, and finally at the bottom, a section on neighbourhood level poverty and exposure variables, plus any relevant interaction with these neighbourhood level variables. And it's this final bottom section of variables which is the particular emphasis of this research project, and which I'll pay particular attention to for the remainder of this presentation. So this is the close-up of the bottom section of that table we just looked at, which looks at neighbourhood level poverty and exposure variables plus any relevant interactions. And we can see here that there are some statistically significant effects of note. Firstly, there is a statistically significant interaction between neighbourhood poverty rate and household size, but perhaps more interestingly, there is a statistically significant interaction effect between exposure to socioeconomic inequality and perceived social mobility history, and exposure to inequality and expected future social mobility. And I'll take each of these last two interactions in turn and look at them graphically. This chart shows the interaction between past social mobility over recent years and exposure to socioeconomic inequality. Now, before starting to discuss the gradients of the results, I will first explain how to interpret the charts. On the x-axis is the exposure to inequality score from the perspective of the poor population, where a score of 0 is the lowest theoretically possible exposure score, and a score of 1 is the highest theoretically possible exposure score. The y-axis represents odds ratios relevant to the respective reference category and is shown on a log scale. There are a series of reference lines shown on the main chart area. Firstly, the grey dotted horizontal reference line denotes an odds ratio of 1. The black dashed vertical drop line represents the mean exposure score for the poor population, poor subgroup. We then have the blue vertical drop lines, which represent respectively 1 standard deviation below mean and 1 standard deviation above mean on the exposure score. And we have the red vertical drop lines, which represent the minimum observed exposure score for the poor population and the maximum observed exposure score for the poor population. Now, the reference category for the past social mobility variable is people who perceive themselves to have been upwardly mobile over recent years. And we can contrast responses on the dependent variable between these upwardly mobile reference group and the 2 other categories of past social mobility, those being people that perceive themselves to have experienced no mobility, which is denoted by the blue gradient line on the chart, and those who believe themselves to have been downwardly mobile over recent years, which is shown through the red gradient line on the chart. At the mean exposure of poor level, which as I said is denoted by the black dashed vertical reference line, people who regard themselves as having suffered downward mobility over recent years show significantly greater aversion to income inequality than people who regard themselves as being upwardly mobile. Specifically, the odds of giving a response on the inequality aversion dependent variable above any particular response threshold are 1.40 times greater for a respondent who perceives him or herself to have been downwardly mobile over recent years than for a person who is identical in every way except for perceiving him or herself to have been upwardly mobile over recent years. However, the relationship between perceived recent social mobility and the inequality aversion response variable can be seen to vary according to the level of exposure. The negative slope of the red line on the chart indicates that, as exposure of poor increases, people who regard themselves as being downwardly mobile become progressively less averse to income inequality compared to people who regard themselves as having been upwardly mobile. So, when the level of exposure is 1 standard deviation below the mean exposure, the odds of giving a response on the inequality aversion dependent variable above any particular response threshold are 2.06 times greater for a respondent who perceives him or herself to have been downwardly mobile over recent years than for an identical person who thinks that they have been upwardly mobile. In contrast, when a level of exposure is 1 standard deviation above the mean, the odds of a self-perceived downwardly mobile person giving a response on the inequality aversion variable above any particular response threshold are only 0.96 times as high as a person perceiving recent upward mobility. So, in geographical areas where inequality is perhaps not particularly obvious on a day-to-day basis, people who regard themselves as having suffered downward social mobility tend to have greater aversion to income inequality than people who regard themselves as having enjoyed upward social mobility. This finding could potentially reflect a greater optimism among upwardly mobile people that life is improving in various ways and therefore greater income and social status may be forthcoming. Whereas for downwardly mobile people, it may seem that the gap between the haves and the have-nots is getting wider and progressively less bridgeable, thereby making the income inequality in South Africa seem increasingly unjust. At the other end of the exposure of poor spectrum, where people are exposed to the obvious signs of income inequality on a daily basis, the results suggest that downwardly mobile people are less averse to income inequality than upwardly mobile people. This result is rather unexpected, but could potentially be due to disillusionment amongst the upwardly mobile population, with their chances of ever spanning the divide between the haves and the have-nots. It is important to note, however, that the lower aversion to income inequality of upwardly mobile people only applies where the level of exposure of poor is approximately 1 standard deviation or more above the mean exposure of poor score. And so, in the majority of cases across South Africa, upwardly mobile people will typically be less averse to income inequality than downwardly mobile people. This next chart, which also relates to Model A, focuses on the interaction between expected future mobility and exposure. Here, the reference category for expected future mobility is people who believe their social mobility will improve over the coming years, and we compare that against people who think their future mobility will either stay the same, worsen, or who are uncertain. Now, at the mean exposure of poor level, people who expect their societal position will improve over the coming years are not significantly different in terms of aversion to income inequality than people who think their societal position will stay the same or worsen or who are uncertain. Furthermore, there are no statistically significant differences in how exposure to inequality affects aversion to income inequality between people who think their social position will improve, stay the same or worsen. However, there is a statistically significant difference between people who think their social position will improve and people who are uncertain of their social mobility future, in the way that exposure of poor affects views on income inequality, on inequality aversion. In geographical areas where exposure to income inequality is relatively low, people who are uncertain of their social mobility futures tend to have a greater aversion to income inequality than people who think their social position will improve. Specifically, in geographical areas with the lowest observed exposure of poor score, the odds of giving a response on the inequality aversion dependent variable above any particular response thresholds are 3.70 times greater for a respondent who is uncertain about their social mobility future than for a person who is identical in every other way other than expecting their social position to improve. As the level of exposure to inequality increases, however, people who are uncertain of their social mobility future become progressively less averse to income inequality compared to people who expect to enjoy improving social status. So, in areas with the highest observed exposure of poor score, the odds of someone who is uncertain about their future social mobility giving a response on the inequality aversion variable above any particular response thresholds are just 0.31 times those of a respondent who is identical in every way other than expecting their social position to improve. So, where exposure to inequality is low, people who are uncertain about their future tend to be more averse to income inequality than people who think their situation will get better. As exposure increases, people who are uncertain about their futures become less averse to income inequality compared to people who expect an upwardly mobile future. This finding could again be related to disillusionment amongst people who are expecting to see improvements with regards to the size of the gap between the very affluent minority and the poor majority, and the difficulty in bridging that gap. In summary, for Model A, the only two statistically significant interaction terms shown in the figures both exhibit negative associations with exposure, meaning that as exposure increases, respondents in these two groups show progressively less aversion to income inequality than respective reference groups. If we now move on to look at the results of Model C, which is agreement amongst the poor subgroup that the government has a responsibility for redistributing income from those on high incomes to those on low incomes, we can again see the overall results table, which consists of a section on respondents' personal and household characteristics, a section on respondents' attitudes and views, and then again at the bottom a section on neighbourhood level poverty and exposure variables, plus any relevant interactions. It's worth noting here that there were no statistically significant variables retained on the geographical location section of variables in this model. So again, focusing on that bottom section of explanatory variables relating to the neighbourhood level variables and any interactions with the neighbourhood level variables, we can see that particularly there are two sets of interesting interactions, one between exposure to inequality and employment status, another set between exposure to inequality and self-rated poverty status. And we'll take each of these in turn. So this chart is set up in exactly the same way as the ones preceding it. This one looks at employment status and exposure. The reference group for the employment status variable was people who are employed full-time, and again the y-axis is presenting odds ratios on a log scale, and the x-axis again is showing the level of exposure to socio-economic inequality from the perspective of the poor, ranging from a low of 0 to a high, theoretical high of 1 on the x-axis. The various different categories of employment status are shown by the different coloured lines you see in the legend, and again these are all showing in relative to the reference category of employed full-time. So at the mean exposure of poor level, which again is denoted by the black dashed vertical reference line, people who are employed part-time and people who are unemployed and not looking for work both show significantly stronger agreement than people who are employed full-time that it is the government's responsibility to reduce income differences between those with high incomes and those with low incomes. So specifically, at the mean exposure of poor level, the odds of an employed part-time respondent giving a response on the support for government redistribution variable above any particular threshold are 1.90 times greater than those of a respondent who is employed full-time. And similarly, a respondent who is unemployed and not looking for work has odds 1.71 times greater than someone who is employed full-time, all other things being equal. It is also evident that 4 of the employment status groups show statistically significant differences in the way that the exposure of poor variable influences the response variable when compared to the way that the exposure of poor variable influences the response of employed full-time respondents. These 4 groups are employed part-time, unemployed not looking for work, permanently sick or disabled, and other. And I'll show these with the respective p-values on the charts. The interaction coefficients for these 4 employment status groups are all positive, meaning that as exposure of poor increases, members of these 4 groups become progressively more supportive of the government's responsibility to redistribute income when compared to people who are employed full-time. So specifically, at the 1 standard deviation below the mean on the exposure of poor score, people who are employed part-time have odds just 0.9 times those who are employed full-time of answering above a given response threshold, whereas at 1 standard deviation above mean on the exposure of poor scale, the odds for an employed part-time person are 4 times greater than people who are employed full-time. Similarly, at 1 standard deviation below the mean on the exposure of poor variable, the odds of an unemployed and not seeking work respondent of answering above a response threshold are 1.14 times greater than employed full-time, and at 1 standard deviation above mean on the exposure of poor variable, these odds increase to 2.56 times greater than people who are employed full-time. Respondents who are permanently sick or disabled have odds at the 1 standard deviation below mean on the exposure score of just 0.3 times those of people who are employed full-time, while at one standard deviation above the mean exposure of poor, the odds are 2.21 times greater than people who are employed full-time. And finally, for people who state that they are in an other employment status, the odds are 0.4 times those of people who are employed full-time at one standard deviation below mean exposure, but these increase to 1.86 times greater than employed full-time people at one standard deviation above mean exposure. These statistically significant interaction terms are all positive in direction. The other non-significant interaction terms are also seen to be positive in direction, but the lack of statistical significance means that caution must be exercised in assuming that this positive direction is necessarily true. However, based upon the results here, it is possible to tentatively conclude that, on the whole, those respondents who might be regarded as involuntarily excluded, either fully or partially, from the labour market, tend to be more supportive of the government taking responsibility for income redistribution than people who are in full-time employment. Furthermore, there is some evidence that as exposure to socio-economic inequality increases, people who are involuntarily excluded from the labour market become even more supportive of government role in income redistribution compared to full-time employed people. These findings may be related to increased feelings of income vulnerability amongst people who are excluded from the labour market. Those who are employed part-time may wish to work more, but may struggle to find employment opportunities and may be in relatively insecure jobs. Those who are unemployed and not seeking work may be discouraged work seekers who feel it is pointless looking for jobs due to scarcity. And those who are permanently sick or disabled may feel particularly disadvantaged in the labour market due to their inability to obtain and or retain jobs. It is not clear what employment statuses constitute the other group, but these too may potentially be vulnerable or disadvantaged positions. Finally, moving on to the fourth chart in this presentation, the second one from within Model C, we look at the interaction between self-perceived poverty status and exposure. Again, the y-axis shows odds ratios on a log scale, with the reference category here being people who perceive themselves to be wealthy or very comfortable, and the x-axis showing the exposure to inequality scores from the perspective of the poor. The categories of self-perceived poverty status that are being compared against the reference category are reasonably comfortable, just getting by, poor, and very poor. In terms of self-perceived poverty status, at the mean exposure of poor level, people who regard themselves as just getting by or as poor are significantly less supportive than people who regard themselves as being wealthy or very comfortable of the notion that the government is responsible for redistributing income from those with high incomes and those with low incomes. Specifically, the odds at mean exposure of poor for people who are just getting by are only 0.43 times those of people who regard themselves as wealthy or very comfortable, while the odds at mean exposure of poor for people who regard themselves as poor are just 0.53 times of those of people who regard themselves as wealthy, very comfortable. The odds at mean exposure for people who regard themselves as reasonably comfortable or very poor are lower than those who regard themselves as wealthy, very comfortable, but the differences are not statistically significant. In terms of the gradients of the interaction terms, of the four subgroups shown in the chart, only the line for people who are just getting by is significantly different to the wealthy, very comfortable group. As exposure of poor increases, people who are just getting by become progressively more supportive of the government's role in income redistribution compared to people who are wealthy or very comfortable. Here, it is evident that at one standard deviation below mean exposure, the odds of someone who is just getting by answering above a given response threshold are just 0.42 times those of someone who is wealthy or very comfortable, whilst at one standard deviation above mean exposure, the odds are just 0.77 times those of someone who is wealthy or very comfortable. Indeed, at the highest actually observed exposure of poor level, the odds for those who are just getting by are 1.52 times greater than those for the wealthy, very comfortable group. But it is clear from the chart that across the majority of the observed exposure of poor continuum in South Africa, people who are just getting by are less supportive of government role in income redistribution than people who are wealthy or very comfortable. The interaction coefficients for the poor and very poor groups are positive, but of a somewhat smaller magnitude than the interaction coefficient for just getting by, and, unlike just getting by, the interaction coefficients for poor and very poor are not significantly different to that for the wealthy or very comfortable group. It may be that the relatively small number of respondents in the Model C dataset that regard themselves as wealthy or very comfortable is the reason why the poor and very poor interaction coefficients are not presented as significantly different to wealthy or very comfortable. One option might have been to recode the wealthy and very comfortable and reasonably comfortable respondents into a new composite category and use that as the reference group. However, after consideration, the decision was taken not to do this here because there is possibly some evidence that the wealthy, very comfortable and reasonably comfortable groups may not necessarily be sufficiently similar to justify combining them. For instance, although the odds at the mean exposure of poor level are not quite significantly different between these two groups at the 0.05 level, the visual representation provided by the chart here suggests there may be a small yet consistent difference between the two groups which may become significant if the number of cases in the wealthy, very comfortable group were larger. Based upon the information conveyed graphically in this chart, and particularly the significant interaction coefficient for people who are just getting by, it is possible to tentatively suggest that increasing exposure to socio-economic inequality may be associated with progressively greater support for government income redistribution amongst the less well-off when compared to those who regard themselves as being wealthy or very comfortable. So in summary, for Model C, in Model C, all 5 of the statistically significant interactions shown in the figures exhibit positive associations with exposure, meaning that as exposure increases, respondents of these 5 groups become progressively more supportive of government's role in income redistribution relative to the reference categories. However, all these 5 interactions suggest that at the lowest actually observed exposure level, people in these groups are less supportive than the respective reference group, although the odds ratios for some of the employment status groups are only slightly below 1 at the low exposure extreme. To conclude, our statistical models were designed to test whether exposure to socio-economic inequality affects attitudes to inequality and options for redress in South Africa. The basic hypothesis articulated throughout this project is that increased exposure to inequality leads to a heightened awareness of inequality, which leads to an increased sense of social injustice and therefore greater aversion to income inequality and a stronger belief that the government has a responsibility to reduce inequality through income redistribution. Our statistical models demonstrated that exposure to inequality does seem to exert some effect on people's attitudes to inequality and options for redress, but the effects are primarily observable through the interaction of exposure with other explanatory variables. In these statistically significant interactions involving the exposure measure, the other variable in the interaction is always categorical. These interactions can therefore be interpreted as measuring the extent to which exposure differentially acts on categories of the relevant categorical variable. However, it is important to recognise and acknowledge one particular limitation of the data. and that is that there is generally a strong consensus amongst survey respondents that inequality is too high and that the government has a responsibility to reduce it through income distribution. The responses on these two variables are typically clustered around the agree and strongly agree end of the spectrum. This means, therefore, that there is not a great deal of discrimination between response categories on our two dependent variables, and this poses clear problems for the modelling. In response to this, our recommendation is that there should be a refinement to the existing survey questions or the inclusion of additional new survey questions that are designed to provide greater discrimination between response categories. And this may result in additional or stronger statistical findings becoming apparent if the modelling was therefore rerun. For further information about the research discussed in this particular presentation, or indeed for further information on any part of the wider project, please contact either myself at the University of Oxford or Ben Roberts at the Human Sciences Research Council. Thank you.